Still, I'm just logging in. Just a moment. MFA code.
Hello, good morning, good evening, sir.
Good evening, Shakil. Six zero seven zero. Okay, now I'm into my management console. Let me share my screen. Okay, so what we are going to learn today? Today we will talk about elastic load balancer and we'll see hands-on of elastic load balancer. So yesterday we have learned that elastic load balancer is of three types. First one is application load balancer, which works on layer 7, HTTP layer. Another one is network load balancer, which works on layer 4, which is TCP UDP layer. And third one is gateway load balancer, which works on layer 3, which is firewall layer. So, and we have seen, we have understood that application load balancer is mostly used, very commonly used in organization to put application behind this load balancer so that customers customers do not get to know about any failures of our server where application is hosted, or customers do not get to know about any zonal issues, any kind of disaster which happens in a zone. It entirely takes taken care by load balancer. So first the traffic falls on load balancer, and then load balancer routes traffic to all the resources behind it. So what we are going to talk about today, we are going to learn quite the same thing in a demo, just to give a kind of idea what we are going to see in our demo. So in our demo, we will talk about, we'll create load balancer. Now the first thing which we have to do is we have to have the backend where our application actually lies. That is the first thing. So where our application lies, now we all know that application basically lies there in our uh, in the in the virtual machine which we have created in past also, where our that IP address which is IP address and some message was getting displayed there in our web browser, which we were accessing by using public IP address of our EC2 instances. So first thing, we are going to have certain, maybe certain virtual machines, and this time we will try to create more than one virtual machine so that you can just understand how the traffic is getting routed in between from one virtual machine to another virtual machine. Because what happens basically is, say in case if there are two customers and in if two virtual machines are there, then what load balancer does is, in order to balance the load across both the virtual machine, it might happen that traffic of first customer falls into, or query of first customer falls into one virtual machine, and query or traffic of another customer falls into another machine. It's like you and I both trying to access google.com. When I try to access google.com, it reaches to some server of Google. When you are trying to reach google.com, it's reaching to some other server of Google. But we both are able to see same web page, which is google.com. Right? So it's quite the same thing. So we will also have two instances, minimum two instances, to understand how the traffic gets routed. This instance will have some public IP. So this instance will have some public IP, some public IP, and this instance will have some public IP. So just for differentiation, I'll name as public IP1 and public IP2 will be there. Now, these both of these instances will be behind a load balancer. So I'll create a load balancer here, and this load balancer will be application load balancer. So traffic. Now I am a user. I, from my computer, will try to access both of these two instances. So there will be two scenarios. First, I'll try to access application which is hosted on both of these instance with public IP1 and instance with public IP2 directly from my machine, which will be allowed because anyways we do have similar sort of security group configuration, and that security group says that traffic from anywhere public IP, which is all zeros, will be allowed. That scenario we will see. Second scenario is we'll try to access application which is hosted on both of these instances through ALB. So first it will fall on ALB, and then ALB will route traffic once to the instance with public IP1 and then to instance with public IP2. We'll see that also. In order to do that, what we will do, we will group together this instance, these both the instance, we will group together and we will try to create a kind of group. We will name it as target group. Target group. Now there can be one or more than one target group. For example, in case if I open a website and I say the website is, for example, Kubernetes dot kubernetes.io. This is one of the Kubernetes website. Now you see the URL kubernetes.io. Now when I open this, certainly this is my query. What I've done, I ran a query on my browser, on my laptop's browser, and that query gave me a web page in return. This is the web page which it gave in return when I queried kubernetes.io. Now I want to access documentation of Kubernetes. So I click on documentation. You see this changed now. This path changed, and this gave me some other web browser. Now, this web browser might be present there in some other EC2 instance. I'm just giving example. I don't know whether it's on EC2 instance or whether it's on Azure Virtual Machine or whether it's on Google Virtual Machine. I don't have idea. But I'm just giving you one example that consider that Kubernetes is hosting this browser, what I'm seeing at this point of time, this dashboard, this web page on say EC2 instance, then they would have created a separate target group with separate set of instances which is hosting, which is having this web browser in it. Now in case if I click on Kubernetes blog, you see this changed. After this kubernetes.io remained same, but after that this blog changed. Now these both are two different, I can say, paths. Each of the path is pointing to different different target group. Quite the same thing can happen here also. Just for the ease of our demo, I'll create one target group only. And in one target group, I'll put two instances. But you can create more than one target group also. You can just route the traffic based on your target group also. I'll explain you how to create multiple target groups and how to just route your traffic to different target groups on Amazon Management Console itself. Now we are going to see both the things. First, we'll be accessing these two instances directly. Being a customer, I'll be accessing these two instances because quite the same thing will be defined there in security group of instances. Second thing, we will try to access both the instance through ALB only. We will block the access directly. We'll block direct access to EC2 instances, and we will allow traffic to go to EC2 instances only through ALB, which is the recommended method, which is the method which organizations follow. Organizations do not allow customers to access application which is hosted on servers directly by using IP address of server. They allow traffic only to pass through load balancers. And this is very important for you to understand because going forward, when you will start working as a DevOps engineer or whenever you are going to access any application or exposing application for your organizations to end users, then you have to ensure that the traffic which is reaching out to your EC2 instances or your virtual machine where application is hosted must come through ALB, or it actually comes through ALB. You know or you don't know, it always goes through ALB only, right? So this is the first thing which we'll see in our demo. Okay, let's see it in demo. It will be more clear. to you when we'll see it in demo. So now in order to do that, first thing which I'll do is, as of now, my instance is in stop state. I'll start it. And this is my first instance. It is starting. I'll create another instance also. So this time I'll name it as my second instance. Keep the OS same, which is Amazon Linux 2023. All the values, let's keep same. Instance type free tier eligible, I'll keep same. Key pair, let's give the key pair, which is test key pair, which we are using for our demo. Now select security group. The security group which we are using is launch wizard 2. Let's keep it. I'm just keeping the same like the way I have my first instance. And now here I'll put my that script. Let me just find that script once. Just a moment. Let me just find it once. Okay. So now I'm just going to copy this instance data and put it in here. Same thing which I did with the first one. Same thing I'm putting in my second one also, and launching instance. Now, once I launched instance, it takes few seconds for both the instance to be ready. Let's see if my first instance is accessible. Ideally, it should be, and that will be our first scenario. It takes few seconds for everything to be ready. And this is my second instance. Let's see. Okay, it's not reachable yet, but let's wait for a few seconds. It should be ready in few seconds. Okay. After it gets ready, then what we will do is we'll try to create our load balancer, and we'll try to route the traffic to EC2 instances via our load balancer. And we'll see that. Hope till this part it's clear for you, how to launch instance and how
Yes,
our
sir.
application. Yeah, it's clear, right? Okay. Let me just close and reopen it. It's going to take few seconds. In between, I'll verify the security also. It's fine. Okay, port 22, and it's allowing port 80, which is HTTP, I believe. Let me just edit it once. Let me just see it. Security group, launch wizard 2, and it inbound rules. Yeah, it's fine. So security group 2 is having, this one is IPv6, this one is IPv4, and this one is SSH. So I'm good with this. Yeah, it's coming now. Okay, now you see two different instances. Since both is having two different private IP, it is showing two different IP. You see, IPs for both the instances are different. Other than that, all the values are same, but check the IPs. This is different for both the instance. Why it's different? Because each of the instance which I created is having different IP address, different private IP address. Private IP address of my first instance is 31.0.195, which is this one, 31.0.195. And of my second instance, it is 31.11.220. 31.11.220. Now what's happening? Consider that I'm also a user, you are also a user. Now consider that we both have to access some application which is present on these virtual machines. Now what is this? This is Hello World application. Now what you will get, you will get this IP to access, and perhaps I'll get this IP to access. We both have to customers, a company has to provide two different IPs to their different customers to access same application. As of now, this IP address is different, but this is different just to show you that these are two different machines. But when any company hosts application will be same for different customers. Doesn't matter which IP or what they're using to log in. Just to show you that these two IPs are different for two different virtual machines, I kept this type of application. Otherwise, I could have just kept hello world and you would have seen same message with both the IPs. But that won't be much clear if I do that. Now what's happening is with two different IPs, I'm getting two, I'm able to access application, but my IPs are different, right? What I want to do is I want customer to have one single domain. I want customer to have only one single IP or only one single URL, and that URL will be able to route traffic to both the instances. In order to do that, we'll follow this. So now this part is done. We are able to access application which is present in virtual machine with private IP1 and private IP2. This both is done. Now I'll put these two in a group. While I'm creating a load balancer, I'll create a target group and I'll bundle it together so that traffic gets routed. Now next thing which I'll do is I'll go to Elastic Load Balancer. So in Elastic Load Balancer, which is this one, okay, in case of Elastic Load Balancer, or let me just open it with the name. Application Load Balancer. Seems lots of interfaces are changed. So with Elastic Load Balancer, what happens is Elastic Load Balancer, you see, you're seeing three different options: load balancers, target groups, and trust stores. So we'll focus on load balancer and target group to understand how we create these load balancers, how we create these target groups. As of now, in this region, now this is a regional service. You see, region is getting highlighted here. So this is a regional service. Load balancer is a regional service. So as of now, I don't have any load balancer. Let's talk about target groups. I don't have any target group as such. So now I'll start creating a load balancer. Now I'll click on create a load balancer. And as I click on create load balancer, it gives me three options to choose from: application load balancer, network load balancer, and gateway load balancer. Application load balancer works on HTTP, network load balancer works on TCP, UDP, and TLS, and gateway load balancer works on firewall and other security stuff. Now we'll create a application load balancer. We can create. Now the first thing which it's going to ask me is provide a name of the load balancer. I'll give a name, demo ALB. This is the first thing whenever you are creating any resource in AWS Management Console. And this is pretty much generic to any of the resource which you will be using, which you will be creating by using AWS Management Console. The first thing which it will ask you is resource name. That is pretty much important. And it is a mandatory component. Resource name you have to provide. You remember while I was creating EC2 instance also, the first thing which it asked me to provide is instance name. Same goes to load balancer name also. Now, after I do this, I want it to be internet facing because normally we use load balancer to expose our web servers, which is internet facing. We use that for internet facing a lot. I'll be using it for IPv4 because that is what I'm using at this point. Another
So
thing
can
is,
you explain this internet fa facing thing? I did not understand.
okay, so for example, any of the application, I'm able to access this kubernetes.io because this is just a page which is hosted on a web server. When I was running this script, what I did, when I was running this script, what I did, I first installed a web server, which is HTTPD. I started the web server, which is HTTPD, and enabled it. Then I hosted this some website, which is in HTML index.html format. I hosted some website. Now, any application which is hosted on a web server so that we as in customer sees it by using some www interface, by using some www protocol, is known as a internet facing application, is known as some public exposed application. So this is what it's about. We are going to use load balancer to expose our any application which is internet facing, which is accessible by customer, which is accessible by customer across the globe over the browser by using some URL. This is called internet facing application. Got it?
Yes, sir. Thank you.
Yeah. Okay. So now this is called internet facing application. So now I'm going to use IPv4 for that purpose. Next is VPC, and in VPC let me just this. Okay. Now IPv4, next is VPC.
Sir,
I'm going to
what is
use
VPC here?
VPC is the okay, like in terms of networking, what happens is you have, for example, you have on-premise data centers wherein your organization do have many switches, do have many routers within it. Now, you being a networking engineer has to create one virtual isolation in between networking offerings which you are offering from one customer to another customer. Right? You being a network engineer, what it will do, you will create a kind of virtual isolation so that you can segregate the traffic, you can segregate the networking resources which you have allocated to one customer from another customer. VPC is that virtual isolation which Amazon does in order to offer networking resources to their customers. Because Amazon is huge, it's very big. They're having thousands of networking switches, thousands of routers, and so many other networking equipments. And they have millions of customers. They don't want, any of the customer don't want networking equipments or networking traffic which is reaching to their application to be exposed to other customers, because this will be a kind of security breach. What Amazon does, Amazon creates a VPC, a kind of virtualization for networking component offering from one customer to us to another customer. That is called VPC, virtual private cloud. It's a private cloud offered to each customer, which Amazon does in a kind of virtual manner. It's not a physical. It doesn't mean that if there are two customers, they are getting two different switches. It might happen that customer one and customer two is having their traffic routed through same switch, which is having perhaps maybe 1028 ports. But what they do, they have created a virtualization on switch level itself so that certain ports in the same switch get allocated to one customer only. Traffic from certain switch, from certain ports goes to one customer only, and traffic from same switch but another ports go to another customer. This is called a virtualization, a virtual private cloud. This is VPC. Got it? You are a
Okay.
networking engineer. Hope you'll understand this.
Yeah, I understand.
Got it, right? Okay.
And above that, there is a dual stack without public IPv4. Only
This
it is
is
mentioning IPv4 i6, but what is stack here?
again, this is stack means for IPv4, what
St-
happens is application which is created with IPv4, like IP version 4 type of
mhm.
CIDR ranges only. But
Okay.
there could be certain application which is created by using which is having affinity, which is having access to both version 4 IP address and version 6 IP address, and certain which
Yeah.
is having configuration to version 6 IP address only and not version 4 IP address. That's about that.
Are we doing some stacking as well? Like stacking is, connecting to switches router into one logical router, that is stacking.
No, no, we are not going
So
to do
is it
that.
like same?
No, no. I mean, internally it's the same, yes, but that is a kind of managed service by AWS. We won't do that. in lab, and we even will never get to know even what is there at the back end because it's entirely managed by AWS. Understood, right?
Okay.
Okay. So now when we go to we are talking about VPC, so we are just going to choose a default VPC because that is what we do have at this point of time. IP tools, not to worry about that. Using IPM tool for public IPv4 address. I do have already public IPv4 address. I'm not going to choose that.
So just
Availability
last one.
zones.
VPC IPs is coming by default, the pool that you selected.
Yes, yes. It will come by default because
Just scroll down. Yeah. VPC scroll down. Yeah, here.
this is
172.31. This one.
right. So this is what? This is the private IP address, which is so what happens whenever you create a kind of private cloud, you will allocate certain range to that to that cloud. So any of the subnets, any of the networking components which gets created
Mm-hmm.
will be allocating IP address from that range only. So consider this is a kind of bigger range. All the smaller components which will be created within this private cloud will be using some or the other IP address of this range only. For example, as of now, what is this? This is like 16-bit cider range because first two octets are filled, last two octets are not filled. So what will be the range? The range will be from 0 to 255. So the
Right.
third octet will take IP address
Two.
from 0 to 255. Same goes to fourth octet also. So how many IP addresses is available in this range? 255 into 255. That many IP addresses are available in this range, whatever it is.
Yes. Right.
Now, you see this instance which I created in this VPC. What is the IP address? 172.31.11.222. This one 172.31.0.195. This is in the same range, right? This is in the
Right.
same range of
Same
this.
range.
So any of the components, any of the resource which I'll create within this VPC will take the IPs in the range which is allocated to this private cloud. Understood, right?
Okay.
Okay.
And the availability zones, it is segregated again. AP South, ABC.
Yeah. So what is this availability zones? These are different data centers.
Okay. Data centers. Okay.
These are different data centers. Now there are in AP South one, which is in Mumbai region. Perhaps there are three different data centers, three different Amazon data centers are present. They named three different data centers as AP South 1A, AP South 1B, and AP South 1C. So these are basically three different data centers, physical data centers. Let's choose all
Hmm.
the three. Now see the subnet allocation for first data center 172.31.32.0/20. Second one is 172.31.00/20, which is another range. Third one is this range. So in three data centers, three different IP ranges were allocated. Now, what is subnet? Subnet is nothing but smaller IP ranges. It's nothing different. Then subnet is the IP range, which is a kind of subset to the IP range which is allocated to VPC. Simple. Now, coming back to security group. Now, this is the interesting part. See, we have created a security group for EC2 instance, right? Now, why we created security group for EC2 instance? Because we wanted to have some traffic, some firewall, some restriction to the traffic which is reaching to EC2 instance. Now, same set of security group we have to create, which will act as a firewall for my load balancer also. I'm not going to use the same one which I created for EC2 instances. I'll use a different one for this so that I can segregate it. So create a new security group. So what I'll do, I'll say not all traffic, only HTTP traffic, because I'm creating application load balancer, which is capable of taking HTTP traffic. Destination, I'll say from anywhere, it's already chosen, anywhere, and give some description. This is for application load balancer, right? So A gave some description also to it. And you see, it's asking for name also. So I'll say demo ALB SG description. I'll give same description. VPC, that VPC only. Inbound rule. Okay. I did some mistake. I should not touch outbound rule because I don't want to disturb outbound traffic. I will only change inbound traffic. Where is HTTP, which works on port number 80 and anywhere IPv4. And I'll change this to this.
Sir, sir, I got confused because we made some changes. Can we do this again, outbound and inbound? One more time, please.
Sure, but see, this is security group, which we have covered in detail previously, right? So this is nothing new, but I'll do it. But this is something which we covered in detail in our previous sessions.
So this is
Can we
inbound.
use the sorry?
Okay, so for inbound, we have to mention the source, which could be any source, and for outbound, you mentioned the destination. So what is this destination going to the instances?
No, outbound rule is outgoing traffic. Inbound rule is incoming traffic. So I mentioned the source because incoming traffic could be from anywhere, and that is the source. When I said source as all zeros, that
Yes.
basically means incoming traffic could be from anywhere. Outbound
Yeah.
traffic,
Yeah.
which is
I have
destination.
confusion with outbound, and I'm okay with inbound.
Okay, so outbound traffic is outgoing traffic, wherein I said that traffic can go to, destination is to anywhere. So outbound traffic is traffic which is going out from my machine to anywhere, to any
Okay.
of the IPs in this universe.
Okay.
That is all zero.
Got it, sir. Thank you.
Okay, yeah,
So,
Shani, you were saying something.
yeah. First, can we use the existing SG security groups that we already defined for EC2 instance?
We can, because there also we do have those rules, inbound and outbound rules mentioned. We can, but I want to differentiate it, that it becomes more clear to you.
Okay, and about the destination IP, normally in the load balancer, we have a common IP that is logical mapping to different servers, but we define the destination IP there. Here we are defining no, it's like open to all the destinations, like traffic is going to anywhere.
Are you talking about on-premise load balancers?
Y- yeah, it's a networking load balancer like that.
No,
We have a
traffic out
destination IPs.
could be in such situation. What happens is you are restricting traffic, and that is also good, because what happens in organizations is, in organizations too, all the employees do not have permissions to access any of the website. And that is where what we do in case of load balancers is we restrict access to certain websites, which is like many of the websites to have malicious content,
Mhm.
which as you access the website, it enters into networking components, in your networking framework. So yes, we restrict the outbound traffic also. In many organizations we do that, wherein you won't be able to open. It will say that as you try to open, it will start giving you the message, say in case if you want to access, raise a request to network team, and they will open that route, that domain to you. Yes, it does. As of now, we are opening everything, But yes, you can have some specific IP ranges or domain ranges in outbound rules also.
Okay. Yeah. No, that's my clear. Yeah. Thank you.
We'd see that, right? I mean, in organizations,
Mhm.
we are not able to access any of the website. We do have some restrictions, and those restrictions are because outbound rules do have those restrictions defined within it. Okay. So now this is inbound rule. So I'm basically creating another security group, which is meant for my this load balancer. So now let's create the security group. Fine. So now security group is created. Now I'll come back to my load balancer. As of now, it's showing default. So I'll just refresh this and I'll click on drop down. And this is the one which, oh, not both. I want to use demo ALB security group only, which is having inbound rules and outbound rule configured. Listener, again, it's protocol port number 80. Now, this is important. Forward to target groups where I want traffic to be routed. I can route traffic to a target group to another URL, and maybe you want to return some fixed response wherein in case if the traffic falls on this load balancer, the message which you can give is maybe something. Maybe if you choose, then you can give some message.
Mhm.
Hey, the message is this site is not accessible. And I'm pretty much sure you would have seen some while you're trying to access some website, at times it gives you a message which says that this site is in maintenance, this site is not accessible at this point, some sort of message you get. By choosing this option, you can do that. Return to some another URL. Maybe I do have already one URL created, already one URL hosted. As the traffic falls on this load balancer, I'm routing traffic to that URL, but you should own another URL also in that case. In our case, we do have a target group, which is again very commonly used framework in organizations. We create a target group. Within the target group, we do have our virtual machines. Those virtual machines are hosting application like the way we do have these two virtual machines, which is hosting our both the applications. Let's create it now. As of now, I don't have any target group. You see, I don't have any target group. So I'll add a target group by clicking here. Or I'll first create a target group by clicking here. So let me just create a target group. Now, in order to create the target group, I do have multiple options, instances, IP address. See, another load balancer could also be another application load balancer could also be a part of target group. Lambda function is again another automation thing which triggers another applications. We are going to choose instances in our case. Target group name, let's give a name as demo ALG DG. Demo
So it is
ALB
not clear,
target
like why you choose the instance
because we
support
have
load
instances.
balancing.
Because we have instances. I want to group like the way here I gave an example, right? What I
Mhm.
said, I do have two instances and I want to bundle these two instances to create a group which will act as a target group for me. I do have two instances. That's the reason I chose instances.
But instances should be the source one, not the destination one.
Instances is the target, is the destination. Where is my application? My application is on the instances only, right? That is the target where traffic has to reach.
Okay, EC2 is the target. Okay.
Yeah, that is where that is where my application is hosted. Say in case if I'm accessing this application,
Mhm.
basically trying to reach to some target. This is my target. This is the target of my query. Similarly, in our case, this is the target. These two applications which we are hosting, this is our target where my traffic has to reach. You're getting my point, right?
No, if we know our targets, I mean destination, then we can define this destination in the rules as well.
No, no, you cannot define. So rules is for different purpose. Rules main job is to act some condition, to add some conditions, not to define the target. First, you should have a target. Then you can define rules on top of it. right? Then you can define some more restrictions, some more filters on top of it. Consider rule is like a filter, but where you will apply filter? You will apply filter. First, you should have a target. Then only then you can apply a filter, right? For example, this kubernetes.io/blog. If I won't have this kubernetes.io, this slash blog will not work. First, I need to have this kubernetes.io. See, the landing page to Kubernetes is this. After this landing page, it's routing to another rule. This is the rule, which is also called paths. This is also called some extensions on the domains,
Okay.
right? So it's like that.
Yeah,
So now,
target group is like server nodes in F5.
yes, in F5 you can say server nodes.
Yes,
Absolutely.
the same concept.
Yes, right. F5 is one of the most highly advanced load balancer at this point of time. Normally used by banking organizations, I've seen. The traffic first falls on F5, then it goes to various other components.
Yes, sir.
All right.
Okay, so now here, target group, I don't have a target group, so let's create a target group. Instances, and the protocol which I wanted to follow is HTTP only, IPv4 address. It's straightforward. Protocol HTTP, IPv4 address, because I have instances which is having IPv4 address only. In case if I'll have instances which has to choose IPv6, I'll choose IPv6. Protocol, there's like different versions of HTTP, it seems. I'm not sure which one will work. I think HTTP will work for both 1.1 or 1 or 2. So I'll choose HTTP 1 only. Health checks. Okay, this is again another interesting thing. Health check is something by means of which I'll be able to parallelly perform health check on my instance also. Like previously I was saying, say in case if my instance stops in between, that my load balancer should not route traffic to my instance, because in case if it does, what will happen? Customer will see outage even though application is up on another instance, but since one instance out of two is down, customer will start facing outage because the load balancer is routing customer's traffic to the faulty instance, which should be restricted. For that, load balancer also imposes certain level of health check on top of instances, which is a part of my target group. This is that instance. This is that health check, which performs health checks on instances, on instance level. And target port, you can choose the target port, which I'm not choosing at this point of time because I want all the port to be open. And let's see, tags optional, no restrictions. Let's go over this page again. So the first thing which I chose was instances because I do have two instances. Next, it asked for my target group name. I gave a name. I chose the protocol as HTTP because that is what the traffic I want. I can choose other traffic protocols also. Say in case if my protocol is HTTPS, I can choose that. And another various protocols also I can choose based on what type of load balancer I do have, what type of traffic I'm expecting. So like application load balancer allows HTTP and HTTPS only, nothing other than this. For network load balancer, we can have TCP, TLS, UDP, and this different type of protocols based on what sort of traffic you are expecting your customers to access. Now IPv4 address, VPC, protocol version, HTTP. Since I chose HTTP protocol, let's say, okay, fine. Give the HTTP protocol version, which I'm choosing as 1. Health check is the health check on instance level, wherein I'm saying, okay, fine. Any traffic which falls on which falls on instance, especially of HTTP type, should be allowed only if instance is healthy, and another fields I'm keeping it as blank. Right? Any doubt in this page? When you will do it, it will be more
But
clear to you.
why are we keeping the target protocol? Oh, sorry, target port blank. Target control.
Yeah,
Target control port.
because I'm exposing at this time all the ports in my
Okay.
this one in my instance. If I give some port, that basically means traffic will reach to my instance through that port only, not any other port.
Okay.
At this time, I'm opening all the ports of my instance. Any other question? Okay. Now let's click on next. And now you see both the instances are running. It says that these are the available instances with me. Select the port and then include as pending. Now let's click on next and create a target group. Okay, now it says unused. It should be running, I believe, in few seconds. It takes approximately 30 seconds for the status to change. It should be healthy. As of now, it's saying 0 healthy, 0 unhealthy. And this is where health check is working. It says 0 healthy, 0 unhealthy, but it takes 30 seconds to 1 minute for all the health check to complete and the status to change from unused to healthy. Okay, let it do its job, and then we will try to add this target group into our ALB first. In between, let it do its checks. Let's come back to our console. And now here, as of now, it's not showing anything. I have to just refresh this for the changes to reflect. And now you see my target group is visible. Now click on this. Now target group stickiness, I'll talk about it later. And let's keep all the values defaults for this time. Let's see listener.
What you change just now?
Sorry,
Just now you do changes, target stickiness.
I did not do any change there. I'll explain
Stickiness.
target stickiness later.
Okay, later. Okay. Bye.
Okay. And listener is port number 80, HTTP1. Okay, I think this one will be good because I'm just allowing the X traffic on port 80, so this should be fine. And Amazon load balancer, these are just the names, nothing much. Let's go over this page again. Load balancer name I gave, it's internet facing, IPv4, VPC. I have selected all the 3 availability zones. Security group, I've created one, and I have for inbound, I have opened port 80 for HTTP, and for outbound, I let everything open. For where is my target group? It will come down, I believe. For listeners and routing, I said fine, let it be this and this. All the values remain same. And now create load balancer. Okay. And now create it. Now my load balancer is created. It is provisioning. Again, it takes some time. In between, let's see the status of our this. Initial. Now see, it's changing. It takes some time for the status to change. In between, if you do have any questions, you can ask. When you will practice, when you will do by your own, things will be much more clear.
So you have selected 3 availability zones, but
Yes.
in this zone page I can see only one by
Yeah.
one.
Yeah.
When it is changing.
The reason is because as of now, the instance which I created is in, see, what is this? This is the availability zone of my instance. It's not the availability zone of my load balancer. Here, the instance is created in same availability zone, 1B. Here,
Mhm,
if we'll come
mhm.
to instance, EC2 and dashboard, these two instances are created in same availability zone, 1B. So these two are not the availability zone of ALB. These two are availability zone of instances.
Can we see the zones for ALB when it is a rotation or in rotational changes from
Yeah,
one to another?
that is cross zone thing, which we'll talk about.
Okay.
Okay. So here in attributes, you see, I can show you that. In attribute, cross zone load balancing. You see, here, once we edit this, we'll be able to see that. But we should have instances across multiple zone in that case. That's any other question you can ask. You can ask till the time it gets created. As of now, I do have two targets, and either of the target is in this zone. Initial, and let's see what is the status of my load balancer. It's provisioning. Ideally, it should take 1 minute. Let's see how much time it's taking. And doesn't matter which organization you will be a part of, you have to deal with load balancers. But I think being a DevOps engineer, you'll have lesser role to play in configuring this load balancer. But if you understand this entire flow of load balancer, how traffic gets routed, what are the inner compositions of setting up load balancer in AWS, it will be much easier. Because nowadays, whenever you say that you are AWS DevOps engineers, interviewers will ask you about application load balancer, about target groups, how you will set up target group, where the target group, how the traffic gets routed to target groups and all. These questions will be asked. Okay, now see, I think this changed, something happened. Now both the instances are healthy. It says 2 healthy and 0 unhealthy. So that basically means my both the instances are good and it's healthy. Health check also went through. Let's come back to my load balancer. Okay, this is also active. HTTP 81 is not reachable because I don't have anything which is going on HTTP 81. I have only two HTTP 80, which is
Sir,
working fine.
the health check 2 came out good. We're talking about health check for the 2 instances, right?
Yes, this is the health check for 2 instances, which shows both the instances are healthy. So now even my load balancer is provisioned, and this is my load balancer. Now what this load balancer, once it's created, what it gave a load balancer ARN, it gave me everything which I need for load balancer. So now if I click on my load balancer, I can see, yes, this is my load balancer which is created. This is DNS name, this is security group, everything, and it's active. So you should wait for your load balancer to show as active even before you start using it. And it's working on port number 80. Network mapping, we'll see it's working on all the 3 zones, 1A, 1B, 1C. Subnets are created, which is used for which is used to segregate the IP ranges. Whatever we have selected while we were creating it, it's showing here. Resource map, whatever it's been created. Security will contain the security group which we have created. You see, this is the security group which we have created. Monitoring, we did not set up any monitoring. By default, it will have its some of the monitoring. Integrations, we don't have anything as such, but this is more or less everything which you need to see whenever you are working on, whenever you start looking at your load balancer, right? This is how your load balancer interface will look like. You see, you were asking about different availability zones. It's visible here. You can see here, you can see here also, both the places you can see. Now, what it gave? It gave, when it created, parallelly what it gave you a DNS name, which is a domain name server name. Now let's see what it is. I'm just copying it now, and I'll put this in my URL and I'll hit enter. As I'll hit enter, you see what it is doing? It is giving me, now you see, I'll close these two, right? I'll close these two. Now with this ALB, I'm able to access application which is present on my instance. Now this is not my instance IP address. I was able to access application which is hosted on my instance this by using my instance IP address till now. But this time I'm routing traffic to my instance through my ALB. Now I have two instances, right? You remember I have two instances, not only one. So ideally, this is my first instance. So ideally, what should happen is if I refresh this, it should route traffic to another instance. Consider this is my first user. My first user is trying to access this application through this IP. You also try to access this from your machine. See, even this IP will be accessible to you also. I'll just post this in Zoom chat. You too try to access it. Let's see what you see. Okay, you too try to access it. Now, but you see what happens in case if I refresh the page, and this will be interesting. As I refresh this page, what happens is this IP should change to another IP. And if it does, that basically means my both the instances are healthy and working fine. But it's taking some time. Let's see.
Yeah, it is changing at my end. It is showing 220.
Changing, right? So that basically means my traffic is getting routed to both the instance this time. Now, not by using two different IPs, right? But rather with the same domain, with the same DNS. And that DNS belongs to whom? That DNS belongs to the DNS of load balancer. So my traffic is falling on load balancer DNS, and it's the responsibility of load balancer now to route traffic to my both the instances. Getting my point, right? You are able to understand the flow, right?
Oh,
Yes, no,
yes, it is.
yes.
It is clear.
Cool.
I only stuck where we stuck, multiples AZs, availability
AZs.
zones. Yeah,
Okay,
because that
because
time we selected different ABC, right?
right,
So normally in a data center, or you can say we have setup of EC2 instance, like in a single data center,
right.
right? And we selected three data centers there. So
So what it basically means, it
yeah, here it is.
basically,
Yeah.
yeah, see, still load balancer is capable of routing traffic to instances in three data centers. Yes, it is capable. As of now, I do have virtual machine present in one data center only. I don't have virtual machine present in another two data centers. But this load balancer is capable. So as I will create instances in another data centers and I will add those in my target group, it will start routing to those availability zones also. As of now, these two instances are present in 1A only, but I can have instance created in 1B, 1C also. This load balancer will start routing traffic as I'll add those instances in the same target group. It will start doing it, as simple as that. It is capable. You are capable to do 10 things, but
Mhm.
in order to perform 10 things, there should be proper accessories, there should be proper equipments available. Those equipments are not there. So what you will do, you will perform two things and you will start sitting idle. Same thing is with this ALB also. ALB is capable, but there should be instances, right, in those data centers where it will route traffic, which does not exist at this point of time. But when it exists, it will start routing.
But when we creating EC2 instance, we don't have option to select the AZs, like
No, no,
availability zones.
we
We
have,
didn't
we have,
select.
we have options. You see, I'll show you. For example, when you launch an instance, give
Mhm.
a name of the instance, instance demo, AWS,
Machine. Yeah.
key pair, let the key pair same.
Any key
Yeah,
existing one. Yeah.
now you choose it. Here you see VPC. Now which one you want to choose? You see AZ1, AZ2, AZ3. All the three options are there, right?
Okay.
You're seeing here, right? So now in case if I choose AZ2, it will create in AZ2. If I choose AZ3, it will create in AZ3. And you see it's having availability zone option also. 1A, 1B, 1C, whichever you want to choose, you can create it.
And till now we have selected the default one.
Yes, default one, which is 1A.
Okay.
Every option is
There,
there.
there
Every
are a
option.
lot of option we have not, touch it in this EC2
And we
instance
are not
like
even
this.
going to touch it, trust me, because there are so many options. You don't even need it.
Like auto assign IPs, I'm not aware.
Right,
Below
right.
that, yeah.
That's what I'm saying. There's so many options. If I'll explain everything, it will be too much. So you just know whatever it's required to know about AWS DevOps. Otherwise, it will be very, very, very confusing. Trust me. It's huge.
No, it's look quite easy
Yeah,
for
sure,
networking background engineers, yeah. But yeah, we have
sure.
to go through
Okay,
it.
right. Any other doubt?
It is clear, sir. No doubt.
Clear, right? So fine. This is about ALB, and tomorrow I'll just give you kind of theoretical knowledge only on networking and gateway load balancer. After that, we'll talk about auto scaling group, which will be the last of AWS, which I'll be talking about. After that, we'll move into DevOps. So perhaps tomorrow or day after will be our end of all the AWS discussions. So practice it well. Ask any questions, doubts which you do have. Right? Sounds good?
Yes.
Yeah. So on the left side, we see capacity manager, reservation, and life cycle manager. A lot of things, elastic IPs.
Right.
So what is that? You know,
There are so many things.
we haven't touched it.
That's what I'm saying. There's so many things.
Okay,
Okay,
for
so
DevOps engineer, do we need to learn it, or is it okay that you just teach
no,
us?
you do not need to learn this, but every AWS DevOps job specifically.
Okay.
There are so many options. So if you'll know
Mhm.
everything, then it will be too much.
Then we become architect. Okay.
Okay, then
Yeah.
let's meet again tomorrow, and we'll talk about NLP and gateway load balance. Thank you.
Thank you,
Thank you.
sir. Take care. Bye bye.